All right, hello and welcome. This video is meant to help out if you missed our lab or we weren't able to be together. Here we have a model with a model Earth, a stick that's about 1 meter long, and this is our model Moon, that tinier soccer ball. And they're about to scale. They're about the right size and distance to be a good model for us. Now, further out, we also have our Sun, which is a lamp on a ladder. Normally it'd be much further away if it was to scale, but we'll make do. So we've modified this stick. It's anchored with the Earth part in the center, and then we can take that stick and move it around for a revolution around the Earth. This would normally take place in about 29 days. So again, our Moon, our Earth, but now we kind of have the lights off. We've got that lamp on, and we can see that we have the shadows cast against the wall. And we're going to be looking at that part of our model a little more closely. So for a lunar eclipse, let's go back to our model with the lights off, and closest to the camera is the Earth, touching it there, and then on the back wall we see the Earth's shadow. And then further away towards the wall we have the Moon and the Moon's shadow. Actually see it on my finger if I just kind of move it in there, the Moon's shadow. So a lunar eclipse is what happens on these rare occasions when things just line up right and the Moon moves into the Earth's shadow and then back out. It takes about 2 hours. There's a slowed down and close-up version. Getting darker, the curve of the Earth's shadow being cast on the Moon, and the Moon gets dark. That's what we typically see as the Moon passes through the Earth's shadow. So here's a side view in this diagram. It's not to scale, but you get the basic idea. The Moon is on the far right. The Earth is in the center in the system, and the Moon passes through this dark, shadowy portion of the night sky. But it has to be lined up just right to happen, which is why we don't have them all the time. We'll talk more about that in a minute. So, in our model, we have the Moon moving through the shadow, but as some of you know, the Moon does something else that's kind of unusual during a lunar eclipse. As it passes through and gets to this darkest part of the Earth's shadow, it changes color and turns red. This is often called a blood moon. So what is going on? Well, the path of the Moon happens to go through this umbra, this darkest part. And the positioning, if we look from a top-down model, looks something like this, with the sun's light getting scattered, in this case blue and green light getting scattered, but the red light is refracted more, and it is able to make its way still to the Moon. So this red light passing, if you were to be on the Moon looking up, you might see this, which would be thousands of miles of sunrises and sunsets circling the Earth on the rim or edge of the Earth in the Earth's atmosphere, and all that red light coming down to focus on the Moon. And what you might notice in this diagram is that a lunar eclipse takes place in the shadow of the Earth, so you pretty much really only see them at night. You might see it in the later, after the sun goes down, or in the early morning before it gets bright, but you pretty much have to be on the nighttime side of the Earth to see one. Now, why don't we get these eclipses all the time, or at least, once a month? And that answer is that the Moon does not orbit the Earth all along the equator, but it's at about a 5-degree angle. It's slightly tilted. Now, this is not to scale, but if we look at a scale version, it would look more like this. And so here we have the shadow of the Earth being cast over the Moon. The Moon is just traveling underneath that shadow, and that's when we just see a full moon. There would be no eclipse in this situation. So back to our model, there's the Earth, the shadow of the Earth, the Moon, the shadow of the Moon. So using our model to show the same thing with that 5-degree angle, it's going to travel over the shadow of the Earth, somewhere up in this area. So pushing that stick around as the Moon revolves. This is an average full moon. The Moon is not being cast in the Earth's shadow down here. Just enough of a difference so that the Moon stays bright all night long and we don't have an eclipse. And this is why most months we don't have that. Just traveling over, staying out of the shadow. That 5-degree angle makes that much difference. And it can go above the Earth's shadow, or in this case, under also. It just depends on the alignment and the situation. The main point is most of the time, the moon does not pass through the Earth's shadow. Now, in this illustration at the top and the bottom where it says node, we have that rare situation where they do line up, but it just doesn't happen that often. So, things to remember: a lunar eclipse is about what we see when we look at the moon, the change in the moon. We're not looking at the sun here. We see it at nighttime, and in the process, the moon gets dark and then turns red. So let's switch now to solar eclipses, and we'll take another look at our model. We have the same model as before. The Earth is still in the center. There's a shadow of the Earth and then the shadow of the moon, and our model moon that's actually on the stick. So we can swing this around. This time the stick with the moon is closer to our light source, to our sun, and you see the shadow of the moon crossing over onto the Earth. The moon is there. Let's look at it again a little closer. The moon shadow swinging over and crossing the Earth. I stopped it there just to demonstrate our model moon here in the front, and leaving a shadow that you can see with my finger on the Earth there. So how come these don't happen very often? Well, same answer as our lunar eclipses. Most of the times the moon shadow misses the Earth because of that 5-degree tilt. So it can either cross, and usually crosses, above or below. So in this case, that shadow's just a little bit high. And so this would be new moon. Shadow is not covering the Earth. If I put a piece of paper here right behind the Earth, you can see that in a slightly different way. That shadow passing across, that 5-degree angle making a difference. Actually, we can probably look a little closer. There you go. Now it can go over, and just like before, that moon shadow can also end up going under. So either way, most of the time the shadow does not cross, and that's why solar eclipses are actually kind of rare. Here's the scale model again, and as we zoom in, you can see that shadow is not going to cross over. Now, what happens when it does cross over? What would this look like from outer space? Well, from one of our satellites, you see this, and you should be seeing that dark spot on the photograph, just as we see it here in our model. And again, a satellite view closing in. The shadow of the moon crossing over the Earth. Now, most people do not witness or see a full total eclipse. You really have to be in that sweet spot, right where it's darkest. If you're north or south or near it, you will see a darkening. The sky will get dark, but you won't get that total eclipse unless you're in that dark zone, that shadow zone. This is an image from an airplane, and with a point of view like this, it looks like there is a sunset all around you on all sides. You're right in the middle of that shadow. Now, in these images, you can see that you have to be on the daytime side of the planet to see a solar eclipse. People at nighttime on the other side will not see it. So what you will see, if you're lucky enough to see a total eclipse, is as that shadow passes, the sun gets progressively darker as the moon gets in the way, and eventually the moon lines up, if you're in the right spot at the right time, perfectly over the sun. We see the corona, the ring or crown around the sun, but we can't see the sun itself. And at this point, it's actually okay to take off your special glasses and look directly at it. And even if it's in the middle of the day, the sky gets quite dark. This picture may have been taken at noon. It takes about 2 hours for that shadow to pass over the surface of the Earth, and then it is over. Still, this leaves us with the question, what would you see if you were standing there on the Earth looking up in the sky? Well, let's use our model, and I'm taking that stick and I'm sliding it over to block out the flashlight, and maybe we need to get closer. Let's use a closer view. That stuff you see in the air is just dust, but we can see that corona, that ring around the sun. With even closer view, starting to block out, lining right up. is our solar eclipse. Very much like what we see in those classic photographs. That ring around the edge we call the corona or crown. It's not the actual sunlight, it's just what's coming off of the sun at a distance. Now, what you do see here are two eclipse images, but you'll notice they're not really exactly the same. The one on the right is a classic total solar eclipse, and the moon is totally blocking out the sun. But in the one on the left, we see more of they call it a ring of fire. The sun is not completely blocked out. It's almost as if the moon is bigger on the right and a little bit smaller on the left. But it's not a change in the size of the moon, but the change in the distance. When the moon is a little bit further from the Earth in its orbit, it can't cover as much of the sun. And the moon's orbit is not perfectly circular, it is elliptical, so we get this effect. We can have a partial eclipse on the far left, an annular eclipse in the middle, which is what we we're just talking about, and a total eclipse on the right, which is that classic total eclipse look that we think about. Now, that partial eclipse on the far left is what happens when the moon passes by, but it's just a little bit too high or a little bit too low. It covers a good deal of the sun. It does get darker in the middle of the day, you can notice it, but it just does not cover the complete disk of the sun. And again, that's because of the tilt of the moon's orbit. If we were to look at this model version again, if the moon was just a little bit lower instead of right in the bullseye, we would have a partial solar eclipse. And so there you have it, lunar and solar eclipses. If you ever have the chance to see a total eclipse of the sun, I highly recommend it. I have seen one, and I know I will travel to go see more in the future. They are really amazing. So we'll finish up with this image, lunar and solar eclipses. Thank you for watching. Hopefully this video expanded your thinking or understanding just a little bit.